Hey guys, and welcome back. So this is the preview of the sim, and pretty happy with the results. We're getting all the explosions that we need, and this is how you would destroy and create multiple impacts and multiple explosions on the geometry. You can see we're getting all the bendings here that we need, and the reason it still works even though we're deleting the pins and stuff is because when we delete the pin, so for example, this cluster here, we're only deleting a portion of it, okay? And then the force is applied there, but all this is still pinned to the geometry. So it's going to work properly. So we don't have to worry, even though if we delete certain amounts from the pin constraint, it's still going to work nicely. And I want to show some more different views for the sim. And you can see how things are getting pushed and deforming. See that nice bend, and here too. This is all very natural and very realistic. It's actually really hard to get that stuff. And the wood is also, let's take a look. The wood is also working because of everything is properly interacting to that push C there, because the wood is attached to this thin concrete sheet, and then it's gonna do this. Okay. Cool. So one last thing I want to add is right now the explosions have the same intensity, the same force, and I want to show you guys an idea on how to control that amount. So let's go back here and let's find and let's copy, or let's connect this here. So we're computing the normals based on the velocity based on the tangent, and what I'm going to do is I'm going to add a measure sub. I want to measure these primitives, and yeah, that's fine. We'll leave that name, and then I'm going to promote this from point to primitive, from primitive to point. And now we should have an area attribute. Cool. So let's do this. Let's put down a wrangle node. And at first I'm going to normalize current V and then multiply it by the area. And this way, if we scale the object, let's put down transform, or let's use this. I'm going to copy it. So let's take a look at the velocity. Let's compute the length so we can see it. F length, or magnitude, is equal the length of V. Okay, and let's take a look at this guy. So magnitude is 25 at the moment. And if we scale it down, the magnitude is lower, which means the velocity is weaker. So this way we can, when we do the impacts forces, if we scale it too big, it's gonna make the force stronger. If we scale it down, it's gonna make it weaker. So we just have to multiply down the force in DOPS to compensate for this new multiplier, which is based on the area. So a value of 25 has been added to the velocity amount, and now we can we have to tweak for that, but we also get variation based on how big this guy is. So let's take a look. Let's connect this, and let's take a look at the magnitude. So here's 28, 26, 17, that's smaller, 23, and that's going to be used as a multiplier. And this way we the velocity, when we sample it into the VDB field, it's going to reflect that. So if we didn't like the velocity amount of this guy, but we like everything else, we can just scale it down here. Okay, and if that doesn't work, if that didn't fix it, we can always add a custom attribute, say mult, and it's equal to 0.5 here, and then mult is going to be, let me do this, I'm going to disconnect this. I'm declaring a multiplier of 1 on all these guys, and then a multiplier of 0.5, and here inside this node we can just use that mult as well, and that will reduce it only for this section, and it's gonna be the same. So we can declare this per section, and that's gonna be our top multiplier if we wanted extra control. And that's pretty much it for the force. The next thing is we're gonna add the ground, which is the last remaining piece of this, and then we will be done with this week. Thank you guys for watching, and see you in